The other kind of special trinomial that's easy to factor, I guess, is the perfect square trinomial. Easy to factor, just a little bit more involved in identifying though. So here's an example of one. So when you factor a perfect square trinomial, what you're looking for in order to identify it as a perfect square is the first term needs to be a perfect square. So x times x is x squared, that works. The last term needs to be a perfect square. 3 times 3 is 9, so that works. And the middle term needs to be twice as big as the square root of the first times the square root of the last. So just to write that out, it needs to be twice as big as the square root of the first term times the square root of the last term, which is 3. So 2 times x, 2x, times 3 is 6x. So that works out. Needs to be twice as big as the product of the multiplication of the square root of the first and the square root of the last. So 2 times x times 3, or 2 times 3 times x, gives us 6x. Great. So we've identified it as a perfect square trinomial. Now to factor it, again, piece of cake. The perfect square trinomial means I've got something, some factor, being squared. Some factor times itself. What is it? Well, what times itself gives x squared? X. What times itself gives 9? 3. And to determine the sign, because this is always going to be positive, a number times itself is always going to be positive, look at the first sign, and that will tell you what it'll be here. X times 3, 3 times x gives us 6x. Okay? Let's take a look at another one. In this case, you'll notice that the first term and the last term are not perfect squares, but they do have a common factor in all of them, and so let's pull that common factor out and see what happens. We get x squared minus 22x plus, what's that, half of 242, 121. Now, x squared is a perfect square. 121 is as well, and positive 121, that's 11 squared. So x times 11, 11x, times 2, 22x, works out. Okay, so we've got a perfect square trinomial. That means that our factors are going to be 2, the greatest common factor, and some factor squared. The first term, square root of the first guy. The second term, square root of the last term. And the sign is whatever that middle sign is, negative. I could write it a different way. It's the same thing as saying 2 times x minus 11 times x minus 11. And I could have factored this by saying what two numbers multiply to 121 and add to 22. Multiply to 121 and add to 22. That's 11 and 11. So I'd get x and x multiplies to get x squared, and negative 11 and negative 11. Okay, multiply to 121, I guess I should have written here negative 11, and add to negative 22. So it's the same thing. Either one of those is fine. This is what you're more likely to see. Here's one that might throw you off a little bit. Tell me why. You've got a perfect square up front, you've got a perfect square at the end, but there's one thing that's different. I hope you can put your finger on it and tell me that it's not a perfect square because this number is negative 36. And there's no way you can multiply something by itself and ever get a negative number. So it's not a difference of squares. And we can't factor it. Okay, it doesn't work that way. Let's see if we can go longhand though. Are there two numbers that multiply to give negative 36 and add to give negative 12? Well, negative 36, we've got negative 1 and 36. And I'll just complete the list here. And of all of these products, or all these factors of negative 36, doesn't look like there's anything that adds to negative 12. Negative 12 and 3 is going to give us negative 9. Negative 18 and 2 is going to give us negative 16. So it doesn't work. So it cannot be factored. So I hope that helps, and continue looking for these Math 10 videos for some extra help.